Hello everyone. In this presentation I'm going to discuss central limit theorem, and I'm also going to show you how you can apply central limit theorem to compute the various probabilities associated with sample mean. To understand sample limit theorem, you need to have two basic concepts. One is the concept of population, and other is the concept of independent random sample. Population is a large data set, you can imagine in that way, that consists of all possible sampling units. Okay, so I encourage you to read the textbook to get more in-depth concept of population. Now, independent random sample. Random sample means random sampling means it's a method in which you collect the samples in such a way that each unit in the population has the same chance of being selected as a sample. And independent means the samples are independent of each other. They are not related to one another. Now, suppose that you have a population with mean 30 and variance 221. And you have drawn a sample of 38 units. And you can calculate the mean of that sample. Okay. Before you understand the central limit theorem, you got to see that you can draw another sample of size 38 and calculate the sample mean. In that way, you can do this, you can repeat this experiment over 1,000 times. And each of the time, you can calculate an x bar, so you can have a 1,000 x bar. Central limit theorem tells you the distribution of those x bars. So in other words, it says x bar follows a normal distribution with mean same as the population mean, mu, and the variance as sigma square over n. And this distribution actually an asymptotic distribution. That means it approximately follows that distribution. And what it means is that the distribution of x bar is symmetric. If you draw hundreds of thousands of samples, and you will see eventually you will come up with a symmetric distribution. So in this particular case, you have drawn a sample of size 38, and you can see that you have observed just one value in this distribution. And the entire distribution follows a normal curve with the mean of 30 and the variance of 221 over 38 in this particular case. Now, by using this central limit theorem, you can answer three types of probability question. As a matter of fact, there are hundreds of questions or even thousands of questions, probability questions related to x bar, but you can categorize them into one of those three categories. I call them left-sided category right here. This is a left-sided x bar is less than or equal to 26.02. This is right-sided, and this is in between. So in this case, the question is, what is the probability that x bar is less than 26.02? Okay, so let's focus on the question number one. So this is the question number one. So if you think about it, this has a distribution, symmetric distribution, and you are asked to find out compute the probability that the value of x bar is less than 26.02. So this is a symmetric distribution. This is the mean of the x bar, and you are asked to compute this probability, this colored area. So how you're going to do that? I can show you a very easy way of doing it by an Excel spreadsheet. So this is my Excel page. So x bar is less than 26.02, and you're trying to find out this area. It's a two-step process. Step one, convert x bar to z. And this you can do by using the central limit theorem. So this is equal to x bar 26.02 minus mean of the population 30 divided by SQRT, and then 221 divided by 38. So At this point, it should be clear that I can make that conversion because of the central limit theorem. And second point I would like to mention to you is that this is sigma square. So you must, and this is sigma. So when sigma square is given to you, you must take the square root, number one. Number two, if the sigma square is not given to you, rather you have this the variance of the sample distribution. That means S squared is given to you, then you cannot use Z at all. You have to use a T. But that's a different topic. So here it is, 1.65. So when X is less than 26.02, Z is less than negative 1.65. And the corresponding Z distribution will look like this. So you're looking for this area, left-sided probability, this area. And you can compute that very easily by using Excel formula equal to NORMSDIST, norms dist, and then this number, negative 1.65. That's it. So enter. So it is 0.049. That means almost 5% of the values of the Z are below this number. So the probability of X bar is the same way that 5% of the values of X bar are below this number, 26.02. That's why I call it a left-sided probability. Okay? So what about the next question? The next question is X bar is greater than 32.77. 32.77. So this is the next question. X bar is 32.77. We can follow the same steps, two-step process. First we convert to Z equal to 32.77 minus 30 divided by SQRT 221 divided by 38. Right? The conversion is done. It's right here. So it is 1.15. It is 1.15. So this is equivalent to 1.15. Got it? Okay. So these two are equivalent probabilities. How you're going to compute that probability? Well, look at the Z distribution. It is basically the same area. So this is the distribution of X bar. This is the distribution of Z. However, this area and that area are the same. So in this case, you're going to use equal to 1 minus NORMSDIST of 1.15, enter. So it is 0.1257. 507 rather. So this area and that area is equal to this. So this probability and that probability is the same. So you have learned how to compute the right-sided probability. What about the third question, in between? Remember I said only 3 different types of questions will be there. So this is the third one. So let's go back to the Excel page again. So the third one is going to look like this. Now you're looking for 2 numbers. One is the upper number, and other is the lower number. So what is the upper value? Is going to be equal to 33.98 minus 30 divided by SQRT of 221 divided by 38, right? Enter. And the lower value is equal to 26.24 minus 30 divided by SQRT 221 divided by 38. Enter. So between 1.65 and negative 1.56. And the Z distribution is going to look like this. And this area and that area are the same. And in this case, we are going to use Excel formula equal to NORMSDIST, the upper value, which is 1.65, and then minus NORMSDIST, the lower value, this, and you got the probability. That means 80% of the values are in between these 2 numbers. Okay? Thank you.